Hi, I'm John Miles, designer of the 3120A phase noise test probe from Symmetricom. Today, I'd like to demonstrate the use of the 3120A to measure the short-term performance of a rubidium frequency standard. I'll start by showing how easy it is to hook up the 3120A on the bench and jump right into your measurement with very little preparation. We're going to use the 3120A to look at a Symmetricom XPRO rubidium standard. This is a compact high-performance unit that's designed for applications ranging from cellular base stations to satellite and defense systems. The first thing we'll do is calibrate the XPRO's 10 MHz output frequency. Basically, we're going to use the 3120A as a high-resolution graphical frequency counter to help us calibrate the XPRO's output frequency with a cesium beam standard. The cesium standard is connected to the 3120A's reference jack, while the XPRO is connected to its input jack. Setting up a measurement really couldn't be easier. We'll select Acquire from Symmetricom 3120A from the menu and enter the name of the device being tested for our own records. We have several options for customizing both phase noise and stability measurements, but the default settings are fine for most of the common use cases. There's not much to do except to hit Start and watch the data come in. Essentially, we're looking at a live-action strip chart view, so to speak. The 3120A is providing fast, high-resolution feedback in real time as I adjust the control on the XPRO. If you've ever used a counter to make this type of measurement, you'll appreciate just how much easier it is when you're seeing 100 data points per second instead of just one. What's also apparent is that the resolution is far superior to that of any traditional counter. Looking at both the graph and the frequency count chart, it's easy to set the XPRO's fine frequency adjustment precisely where it needs to be. So now that we've calibrated the XPRO rubidium standard, our next job is to see how the unit actually performs. The XPRO's datasheet specifies its Allen deviation out to a 100-second tau interval, so I'm going to start a 5-minute test to ensure that we get good statistics out to 100 seconds. As before, the 3120A starts returning data within just a few seconds. There's really never been a good way to see an Allen deviation trace evolve in real time like this. Not only does our live-action ADEV display give you a unique feel for the short-term behavior of your source, but we can also look at the XPRO's phase noise at the same time. Here we are at the end of our 5-minute run. Now let's look at our data. I've loaded a previously saved plot so that we can compare the XPRO with its predecessor, the LPRO. I've also created some test masks with the XPRO's stability and phase noise specs. You can see that the XPRO achieves its specified short-term performance by a healthy margin, while the older LPRO unit lags pretty far behind. That's true for both phase noise and Allen deviation. So as you can see, the 3120A software application is designed from the ground up to support comparison tests with multiple measurements on one easily readable graph. I'm going to load one more plot here because it's interesting to compare with the others. The dotted green line represents the typical ADEV measurement floor of a high-quality time interval counter, such as an Agilent 53230A series or HP 5370. Now let me switch masks. We'll turn off the XPRO mask and select another mask that shows the 3120A's specified measurement floor. There's just no comparison. The Symmetricom 3120A shows you things you haven't been able to see before without much more expensive and elaborate instrumentation. Thanks for watching.